Hey there, Year 10s, Mr. Herman here, and this little video is going to be dedicated to linear modeling, which belongs to the linear equations topic that we are currently working on. The learning goal for this lesson is to look into a real-life context of linear relationships and the success criteria, so what you'll be able to demonstrate at the end of this video and at the end of your work, to be able to use your skills from linear relationships to solve real-life problems. Now, if you can't already tell from my voice, my little sniffle, I'm currently under the weather and I'm feeling quite sick, and the doctor has taken me off Thursday and Friday. So unfortunately, I cannot be there for both doubles. I do apologize in advance. I'm currently sick, currently looking after two sick kids as well. We've just been slammed with sickness, unfortunately, this week. So I'm hoping for a speedy recovery and hoping to be back next week on Monday. We'll see how we go. So hopefully by now the teacher has provided you with a specific worksheet, and on there is an example which I'm going to go through that will help you tackle the next set of questions. Now, a lot of this does require a bit of logic, but we can work this out in a very step-by-step basis, provided that we understand the context of the question that's going on. So linear modeling just means that we will be given a certain situation that's got some real life context, and we're going to use our algebraic skills to figure out and portray certain information that's asked for and that we can display either graphically or algebraically. So what do I mean by this? Here's an example where the deal offered by NetShare, which is just a company and they're specifically an internet provider, to its new customers is a fixed charge of $20 per month plus $5 per hour of use. So write a rule for the total monthly costs C dollars of using NetShare for T hours per month. Now, before we write what this specific rule is, it's good to get a grasp of and make sense of what's actually going on. Let's say, for instance, that you were to get to this specific internet deal, and we have two things that vary: the time, and this is in hours, and also the cost, which is in dollars. Now, in the very, very, very rare circumstance where this particular household doesn't spend any hours on the internet, say they've gone on holidays or whatnot, there still is a deal that has a fixed charge of some sort of $20. So if we did not use any hours of internet, it's still going to cost $20 because this is a fixed charge. Now, as we keep going up per hour, and we can just do this in increments of hours, after 1 hour there's going to be an additional $5 because it is $5 per hour of use. So the cost for just 1 hour of internet will be $25 because we are essentially adding $5 based on 1 hour. Now this obviously goes up if excuse me, if we are 2 hours. This will cost us 2 lots of 5, which is $10. So it will be $10 plus that initial $20 fee. So all up, this will be $30. And the fact that this is going up by 5, it starts off at 20 and it keeps going up by 5. So this will be $35. This will be $40, etc. So our rule, okay. So what this says is that the thing that varies, obviously the time and the cost, we can't determine what the cost is unless we have been given how many hours has been used by the internet. So the cost C, what our cost is going to be equal to is a $20 flat rate fee or fixed charge. Okay, this is just already been established. Now cost is just not going to equal 20. It's also going to be equal to 5 lots or 5 times however many hours, which is T represented by T, we use for the internet. So this is the thing, this is our input, this is a thing that varies, which we can see the whole list of here. And if I plug in any one of these numbers within this formula, it will then spit out what the cost is. So again, if I chose 4 hours, I would just plug this into this formula. 5 times 4 is 20, so $20 for this part of the portion of the fee, plus an extra $20 for the fixed charge. This gives me my cost is equal to 40, which is what we found out right here. So this rule just represents all the different T values that you can put in. We don't know what the T value is, but we do have a rule that we can depend on to determine our final cost. So the second thing we need to do is we need to be able to sketch the graph of C versus T for T is in between 0 and 10. Now these little symbols here just mean 0 or T is in between 0 and 10, and also including these values. They're called inequalities, and you may have seen them before. What we've got to know is that when we list our different values on the bottom here, we're going to start at 0 and we're going to go up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we can go 11 and 12. Now, depending on how you would position these numbers, if you're going to do this the correct way, it should be in line with the actual line. Some students might shift it across and have them in the form of blocks, but because we're doing proper Cartesian sketching, it should be in line with the actual vertical lines. Now, 0 is the amount of hours, and that's our starting amount. Now, if we were to go up to 12, obviously it's going to have this great amount. It's going to be 5 times 12, which is 60, plus 20, which is 80. Now, I'm not going to go up to 80. In this case, all I want to do is I'm going to make sure that these increments go up by $20, because we do need a starting value of 20 based on the fact that we need to represent 0 hours. So this is 20, this is 40, 60, 80, 100, 110, 80, 100, 110, 120, sorry, 140, and 160, which is here. So C is in dollars, and T is in dollars. There we go. Now we've just got to put a point to each one of these times that represents the relevant costs. So at 0, we're at $20. At 1 or 2, we're at $30. So 2, we're at $30. Now obviously 1 is at $25, which is about here. But I'm just going to go up in increments up to 2, and then I'm going to just connect these via a straight line. So for 4, we're at $40, which is here. And you can see that this incrementally goes up evenly. In fact, we didn't need to go up to 160, but I just put it there just to be safe. So 12, that is at $80, and that makes sense. 12 times 5 is a 60 plus 20, which is the 80. And so all we need to do here in sketching this is do a dot to dot. Now mine's going to be a bit terrible, but you would ideally use a ruler and indicate via this arrow that this keeps going on. So this here is the cost of internet. You will always need some type of title to represent what this graph actually represents. Now we've done the sketching, we need to answer the next 2 questions, and then you can continue on with the worksheet. What is the total cost in a month when NetShare is used for 4 hours? And we've already worked this out here, but if you had to show some type of if you want to show some type of understanding when it comes to your test or when it comes to the actual exam, you write down what the formula is, and you are going to find the cost when the time is equal to 4 hours. And this here is just a straightforward substitution. So your cost is going to be equal to $20, which is the flat rate, plus 5 lots of 4, because this is 4 hours, $5 per hour. This here is just 20 plus 20, which is $40, which is again what we worked out here. And the last question before you guys continue on with set work. This one's a little bit trickier. There's different ways that you can work this out. If the monthly cost was $50, how many hours was NetShare used during the month? So $50. Now you can work this out graphically. You can see here that $50, which is in the middle of 40 and 60, it lines up with this point here, which is at 6 hours. So what this is saying that, again, if our formula is cost is equal to 20 plus 5 lots of time frame, what is this is saying is this is going to cost $50. What is the time amount? So we're kind of reverse engineering this. We're working backwards to see what this is. Well, let's just assume that we'll take away 20 from the $50 because we want to ignore this amount. So what this is $30 is equal to 5 lots of time frame, and all we're doing is just trying to find a number that when multiplied by 5 will give me 30. And the only number that does work is 5 times 6. So that means that this time frame of 6 hours is the only number that can work, and this can be validated by the fact that it lines up with 6 hours here. Alright, so this is how you tackle the second question. The answer is 6 hours. That's my answer. Have a go at the rest of the sheet. Remember, this is the last topic of linear equations. So linear modeling is quite tricky. There's a lot of context that's involved, but just break down the question step by step and you should be fine. Alright guys, I will see you guys in the next video, if there is a next video for Friday's class. Until then, see you soon. Bye.